Okay, today's section 3.2, one of our objectives is to calculate and plot and interpret the regression line between two variables. So your regression line, when you first learned this, probably back in Algebra 1, your teacher most likely called it the line of best fit. It's a really logical name, right? What line best fits our data? Now we're going to talk about it as regression. Okay, you might also hear about it as your least squares regression line. So LSRL, they'll abbreviate it sometimes. It's a straight line, all right, that describes how a response variable y changes as an explanatory variable x changes. Okay, sometimes it's called a prediction equation because we see if we can predict y. Huge typo that I don't know what happened when I made your notes is your Y here needs to have a hat on top of it. Okay, which I know you're like, did you really just call it a hat? Yes, I called it a hat because its official name is Y hat. Okay, Y hat means it's a prediction. Okay, you can't just use plain Y. Y is the Y from the data point. Okay, X is the X from your data points. Y hat is your predicted Y. All right. Extrapolation, I'm actually going to come back to later. But what we do is when we'll talk about it now, when we use an equation to make a prediction, right? Well, that prediction is only valid for the domain of the data points we have. So if our x's, right, go from 10 to 30, and then I say, and we have a line that works for x's being 10 to 30. And I say, okay, now predict what if x was 100? Well, we can't make a prediction for x is 100. That line is only valid where you're in the domain of your x's. So from 0 to 30, your predictions are valid. Lower than 30 or lower than 0 or higher than 30, invalid predictions. That would be extrapolation. So let's go back to that example from McDonald's. Okay, and what I want you to do is in your calculator, go find that sodium and fat list. And I actually still have it up here when we did our linear regression. So if you didn't do your linear regression, do it again in your, stat calculations. The equation is y hat equals a plus bx. Here's the a, here's the b. No, cancel. So here's the a, here's the b. So if you guys take a look at what I filled in, okay, it's y hat equals a plus bx. All right. Now, writing just this will only give you half credit because you need to then also state what x represents and what y hat represents. It's the predicted grams of fat. They need to be in the context of the problem. So if the problem just says find your regression equation, this is everything you would need to include. Okay. Now, we also want to identify the slope and y-intercept and interpret each value in the context. So I'm going to walk you through mine. Your homework, the textbook practice is the chances where you can do more practice on your own as you go through. So the slope for each additional milligram of sodium, all right, your predicted fat is going to increase by 0.021 grams. So each time your sodium goes up 1, it multiplies by this, which means your predicted fat goes up by this much. Okay. Your y-intercept is when your line crosses the x-axis, the y-axis, right? It's when x is 0. Well, our x is sodium. So when you have 0 milligrams of sodium, your x is 0, then your predicted fat grams are going to be negative 0.672. Now that's impossible, right? It's impossible because you can't have negative grams of fat. But it's our best prediction based on the graph that we have, okay? Another cool thing about the calculator, if we go back to the picture of it, here, sodium and fat, you can also, if you go under menu, okay, and then you can come here and analyze, and you can come here in regression. All right, you got to be careful. In regression, we can pick this, show linear a plus bx. Oh, it's a beautiful graph. All right, and you will notice that you have this line. It's obnoxious. So what you can actually do is you can take your cursor, and if you push this center click button here and you hold it down, you can drag the equation away. Okay, so you can drag it out of the way if it's like plopped right in the middle of your graph. You'll see here that your y-intercept is just barely below, just because of this point that was 10 comma 0. Okay, it like changed it a little bit that way. All right, so here's a great way that you can examine that. All right, now this next problem says predict the grams of fat that I meant to write salad. These are all salads, not sandwiches, but that a salad would have if it has 400 milligrams of sodium. So you're going to take 400 as sodium as our x. So you're going to take 400, you're going to plug it in, and you're going to get 7.728 grams of fat. Okay, if we go back to our data set, our x-axis, our domain goes from 10 up to 870. So any prediction between 10 and 870 is valid for x. If I asked you to predict for 900, you could plug it in, you could get the answer, but then you could say, this is not valid due to extrapolation. Okay, now I'm never going to like trick you. The College Board won't trick you like, well, what about 871? Nah, like they're going to either make it really high or like way lower than the domain. Okay, they're not going to go one higher or two higher. I've never seen, I can't promise, but I've never seen that occur. All right, I wouldn't do that. That's not cool. All right, so let's take a look here at the next thing. So now is where, and hopefully all of this is kind of a review of what you guys have seen in your statistical journey so far in your lives. Now we're going brand new. Okay, so the residual. A residual, actually, let me go here to the blank packet. A residual is your difference between your observed value of the response and the value predicted by the regression line. So let me take you back to this picture. Okay. A residual tells you the vertical distance this way from what we thought was going to happen and what did happen. So for instance, this salad had way less fat than what we thought was going to happen. This is where we thought the fat would be at almost 12. And it had 5 grams of fat. This salad, we thought it was going to have like 14 grams of fat, and it only had 9. Whereas this salad, we thought it was going to have, I don't know what, 14, 15 grams of fat, and it had 18. So this salad had more fat, so it had a positive residual than what we thought it would. This salad had less fat than what we thought it would. This salad pretty much has a residual of 0. Okay, it's going to be a really tiny decimal. Technically, it's positive because it's above, but it's barely above. Same with like this guy. It's barely above what we thought it would be. If you happen to have a data point that lands directly on the line, then that one would have a residual of 0. Okay, so what we do, the math for it, because it's not always just graphs, the math for it, what we do, and I actually need you guys to cross off this 400 and change it to the data point 580. We want to find and interpret the residual for a salad that has 580 milligrams of sodium. So the actual data point was 580, 5. Okay, so what you need to do is, the first thing you need to do is you need to plug it in. So you need to find your predicted. You're going to plug in 580 in for your x, and this is your predicted y. Okay, we thought it was going to have 11.508 grams of fat. To calculate a residual, you take your y and you subtract y hat. So it's your actual y minus your predicted y. The easiest way to remember this is we are in AP statistics. AP statistics. All right, so A minus P. Our actual y was 5 minus our predicted y was this 11.508 that we just found. So our residual is negative 6.508. If we go back to that graph, it's this one. Didn't we say, hey, we thought it was going to be right around 12, and we had 5, so we'd have -7, right? I was estimating. Well, here's the actual calculation, -6.508. The other huge deal, guys, remember this class is half number crunching and half interpreting those numbers. Find and interpret the residual. So our interpretation in the context of the problem is the sandwich with 580 milligrams of sodium has 6.508 less grams of fat than we expected. So that would be your interpretation. Okay. So now what we're going to do is we're going to cruise on into this next problem where I want you to find all of the residuals. Okay. So here is trash in millions of tons per year and our population in millions. And we want to see how they're related. So let this be your x-axis. Let this be your y-axis. Okay. So put them in your list. Find your y-hat equation. Okay. Then I want you to plug in each x in for your y-hats. Okay. I extended it as a little table. So I extended it here. Okay. I found my y-hat equation to be this. My correlation coefficient is there, 0.99. And what I did is I took 88, plugged it in for x, wrote down my answer. Take 103, plug it in for x, write down my answer. Take 122, plug it in for x, write down my answer. Over and over and over and over again. Okay? Then these are all my y's. So I can do, hey, my y's, here's a y minus y hat equals my residual. Y minus y hat equals my residual. Y minus y hat equals my residual. Okay, this is a nice way you can organize this. So you're like, this is absurd. There has to be a faster way. Yep, you're right. There's totally a faster way. Okay, and I'm all about embracing those faster ways. So let me teach you something. Okay, and those of you who are comfortable with Google Sheets and Microsoft Excel, you might have learned this as well. So trash and population are our names, and here's my data set. Okay, what I can do is in here, I'm going to call this YY. I can't call it Y, single Y, because I used that the other day when I did the parabola. So I'm going to call this YY, so I have a new name, okay, because otherwise it remembers. I'm going to type in here 126 point, oh my goodness, 0.113 plus 0.656. I can't call it x because my x variable is actually trash. So I'm calling it trash. It just took 88, plugged it in the equation, gave me the answer. Took 103, plugged it in the equation, gave me the answer. Okay, so it did all that for me. Now what else I can do is I can tell it my residual column is y minus y hat, answer. Y minus y hat, answer. My y is pop. My y hat I called YY. And it subtracts them for me. Okay, you can let this work like a spreadsheet. And if you need to pause and rewind what I just did and work through it with me, that's totally fine. That's the beauty of this video concept. All right, these are the residuals that I just did here. Okay, so if you need to find your residuals, you can get them here. The other place you can get them, all right, if you do your linear regression, okay, let me come up here. If I delete this, delete that, and I do menu, stat calculations, a plus bx, and I do trash, and I do pop. Okay, trash and population. And I press OK, right? Here's where I got my equation from. Here's my R squared. I'll show that to you next video. Here's my R we just talked about. Here's the residual. If you hover your cursor over it, I can't move, but that 3.85 Negative 3.85 is the first data point. The 0.306 is for the second data point. The negative 2.159 is for the third data point. Now, you will notice that they're slightly different than the ones I wrote down. And that's because these use the non-rounded A and B. Okay, it uses this entire A decimal and this entire B decimal. So they're going to be a smidge different than the ones I wrote down because I rounded A and I rounded B to 3 decimal points, which is how far you should always round. You should always round A and B to at least 3 decimal points. Okay. So you could also get your residuals this way. There are a million ways you can get them that are faster than plugging in every number by hand. All right. So what you can do, and why we do this, is we make a residual plot. Okay, when we make a residual plot, what we're doing is we're graphing. The ordered pairs that we graph are x comma residuals. All right, so if we have, here's our x's, all right, or our residuals, and here's our x's, I'm going to take x comma residual, plot the point. 103 comma 0.319, plot that point. 122 comma negative 2.145, plot that point. And I graphed my scatter plot. My residual plot. It looks like a scatter plot, but now you have above and below the x-axis, okay? So you're going to have some positive residuals and you're going to have some negative residuals. They're spread out. And what we do with this is we're looking at, is it a good fit or not? Your residual plot is really your backup evidence if your original graph was linear or not. So when we look at our original scatter plot, we want to decide, is it linear or not? Well, your residual plot can help prove that as well. So what happens is if a regression line fits your data well, then your residual plot should show a uniform or even scatter of plot points about the line. So here, this bullet, a uniform or even scatter of plots, right here, they're spread out above and below. It's like a nice even scattering, okay? That means that your original data was linear. If you have a curved pattern, a U this way, or if you had it upside down, a U this way, where you have under, over, under, okay? Curved pattern in your residual plot shows that your original data was not linear. It's more backup evidence. If you have where it looks like a funnel cloud, it's close to the line and then it spreads out as it goes. What that means is that your prediction line is only good here, right? And it's pretty unreliable as you get further away from the axis. Okay, so there's one more thing we can do and then we're done for today. Okay, and that thing is we can actually create an entire residual plot in our calculator. So let's also find that McDonald's example. Okay, here's our sodium and fat. Here's your residuals for that sodium and fat. Okay, now you could just handwrite them and sketch a scatter plot. But you can also, if I come back here, here's sodium and fat. Okay, you can do menu, plot properties. Nope, I'm in my axis, sorry. Do you see how my cursor was in the word fat? Your cursor needs to be on the white part. If you hit menu, plot properties, no, analyze, I apologize, analyze. So if you go menu, analyze, residuals is highlighted, okay? If you pick residual plot, it graphs it for you here. Okay, now this one really is U-shaped. Would you agree? Above, below, above in clusters. So when we originally looked at this, we said, that looks pretty linear, but really it's not. All right, this is curved data, okay, where it's a curve. It's kind of hard to see because it's close together. Now what you notice is this line here, hopefully you see the pattern of points above, below, above are the same. That line there becomes this x-axis. And it tells us these are the above that pair up with these. these three pair with these, and then these three pair with these up here. Okay, so I know that I gave you a lot of information today. These are the homework problems. I forgot to type them in before I ran copies, so sorry. So sit down and try these. They're odds, so they're gonna like pair together. Like sometimes 39 is used in 45 is used in 47 or something like that. So do these problems, work through them, and we're definitely gonna reconvene next class to talk about this.